So I have some things here that I want to calculate. I need cosine, tangent, and secant of this particular right triangle. So there's a couple ways you could do this. First, and I want you to get used to this. This is my angle theta. I don't know what theta is. I don't honestly even need to know what theta is, right? What I need to know is, what is this side across from it? Well, this is the opposite, isn't it? And this is across from the 90-degree angle, so that makes this side the adjacent. And then this one over here, or not adjacent, it's the hypotenuse. I was one step ahead. And then this over here is the adjacent. Hypotenuse across from the 90-degree angle. Oh, I already screwed it up. So, remember though, and I think we talked about this Friday or Thursday, somebody said, well, why do they do the lowercase a, b, c, and why are they, so here's why. If we think in terms of A, B, and C, the side across from the 90-degree angle, we call that lowercase c. If we were to call this lowercase a, and we were to call this lowercase b, we know that the Pythagorean theorem, a squared plus b squared equals c squared, right? You guys have been doing that probably since like 6th grade or whatever. But in trigonometry, we're still going to use those properties, but instead of thinking of it like this, what is a squared in terms of trigonometric definitions? That's the opposite, isn't it? So that's the opposite side squared. Well, what is b squared in terms of trigonometric definitions? The adjacent squared. And then what is c squared? The hypotenuse. So that's very important. From here on out, we might do the a squared, b squared plus c squared, whatever. We might do that. But we should get used to opposite squared plus adjacent squared equals hypotenuse squared. So I've got to solve for the hypotenuse, because here's the thing. Cotangent, or wait, let's start with cosine. Cosine, SOHCAHTOA. I don't need to know the angle for theta as long as I know what the adjacent is over the hypotenuse, right? I don't need to know the angle for theta as long as I know what the opposite is over the adjacent. And since we're saying SOHCAHTOA, remember that sine of theta is equal to the opposite over the hypotenuse, right? The SOHCAHTOA thing that I keep talking about, so, S-O-H, pronounced so, Ka, C-A-H, Toa, T-O-A, SOHCAHTOA. Let's write that down. SOHCAHTOA. You guys should be writing this down. The more you write it down, I got to get it in your brain 27 times. Write it down. All right, so cool. We got that in there. But secant, you guys may not remember this, but secant is the reciprocal of what? Of the three basic trig functions? Sine, or cosine? All you got to do is look in your notes. It's not the opposite, it's the reciprocal. Those are very technical terms. But yes, it is literally the reciprocal of cosine. In other words, it's 1 over cosine. Which always throws people off. People think, oh, cosecant is the reciprocal of cosine and secant is the reciprocal of sine. No, it's not. I don't know why they chose the name. It would have been so much easier for everybody to learn if that's how they did. Well, I do know why, but when they come up with this stuff, they're not necessarily thinking of high schoolers. But anyways, so whatever cosine is, we just reciprocate it, right? Just flip it. Well, if you notice, in all the ones that we need to find, we need the adjacent. So we're going to plug the numbers in. The opposite is 7, right? Squared. The adjacent, I don't know what that is. That's squared. And then the hypotenuse is the square root of 65. All of that squared. What's 7 squared? 49. I don't know what a squared is yet. Now, what happens when you square a square root? Yeah, it's just the base. So this just becomes 65. I want to solve for a, so I have to subtract both sides, 49. Whatever I do on one side, I do on the other. That gets my 49 out of this side and over to the other side. So I end up with a squared is equal to 65 minus 49, 16, right? So then I take the square root of this because I want to get a by itself. And whatever I do on one side, I do to the other. The square root of 16 is 4. So this is 4. So cosine is the adjacent, which is 4, over the hypotenuse, which is the square root of 65. Now remember when we went over this the first time, I said I'm not going to get into it, but we need to rationalize the denominator. You can't leave a square root in the bottom of a denominator. So I've got to square it. Okay. So that means I'm going to multiply this by the square root of 65. And whatever I do on the bottom, I have to do to the top. There's a reason we do it this way. If I tell you what it is, you'll just be like, huh? So we'll get to it eventually. Anyways, what's the square root of 65 times the square root of 65? 65. That's just 65. All over 4 times the square root of 65. That's it on that one. Let's do the adjacent, or tangent. Tangent is the opposite, so this will be 7 over the adjacent, which is 4. So this is the first part of the answer. This is the second part. And then lastly, we say the square root of 65 over 4. Okay? Does that help a little bit, you guys? No? No? Where are we stuck at?
No, I mean, because where did I even get lost? I was with you, then I wasn't with you.
Well, you were talking, though, too, so...
You said what?
You were talking while I was teaching. That might be...
We were not talking.
I asked them a question because you had me at a equals 4 and then you went over the sin, cosine, and...
Okay, well, next time ask me the question, and then I'll answer it. So let's back up. Let's do it right now. What was the question that you asked, though? I was here. So let's back up. Do you know how I got this answer?
Yeah.
Okay. So now that I got that, cosine, SOHCAHTOA, right? SOHCAHTOA. All these tangent functions are just the ratios of the sides of the triangle. And I'm going to go over that after we finish this problem. And that might make a little more sense. But when I say sine of some angle theta, I'm really talking about whatever that angle is, I'm trying to figure out what the opposite over the hypotenuse is, number-wise. Cosine of whatever the angle theta is going to have a value for A and a value for H. Tangent has O over H, the opposite over the adjacent. And then because secant is the reciprocal of cosine, I'm just going to flip that. Instead of it being A over H, I'm going to say H over A. So then I have this, I needed to solve for this. So now I just plug those numbers in. What's the value of the adjacent? In other words, when I measure, it doesn't matter what this angle is. This right triangle, if this side length is 4 inches, feet, it doesn't matter what it is, meters, miles. If it's 4 units, and this is 7 units, then this has to be the square root of 65, whatever the unit is, okay? In order for it to be a right triangle. But because I'm focusing on this angle, I'm going to label this side as the opposite side. Because this is across from the hypotenuse, I'm going to label that as the hypotenuse, or this is across from the 90-degree angle. I'm going to call that hypotenuse. And this is the adjacent. So sine of that angle represents just whatever the number, like if I were to plug this in, and let's start here. What's the length of the opposite side? 7. What's the length of the hypotenuse? Square root of 65. That's it. We're just plugging it in. The only extra part that's a little hard for people is that I can't leave a square root in the denominator of a fraction. So I have to square it. In other words, I multiply it by the square root of 65. Whatever I do on the bottom, I have to do to the top. Then this becomes 7 square root of 65 all over 65. Okay? Same thing over here. If I said cotangent, which is the reciprocal of tangent, that would just be the adjacent over the opposite. Okay? So cotangent of theta, you just plug in the numbers. What is the value of the adjacent side? 4. And then what is the value of the opposite side? 7. That's it. Okay? Does that help?
So they're fractions.
Yeah, and it could be written as a decimal, but yeah, they're just a fraction. It's just the ratio of the two sides. Okay? So I think that's good. I think what we're going to do next will help you understand that a little better. Okay? So I'm